This is part 4, section 4.6. We're going to use the identities to find the exact values of each expression. So we want to find inverse secant of square root of 2, okay? So since this is a reciprocal function, it's probably going to be easiest if I go look for, since this is secant, it would be cosine. But let's see how we make sure that we make this adjustment correctly, okay? I have secant of something and I want to change it to cosine of something. So I'm dealing with one of these two just depending on how you want to look at it. But it does say that these will give exact answers. You don't have to make any sort of adjustment like you do with tangent and cotangent. So it's equivalent to find cosine inverse of the reciprocal of this, which is 1 over the square root of 2, which is equivalent to cosine inverse of square root 2 over 2. And you will get an answer in the first quadrant where cosine is positive, square root 2 over 2, and that is at pi over 4. Okay? Now, similarly, cotangent inverse of negative square root of 3. So I've got a cotangent and I'd like to turn it into a tangent by dealing with the inverse, okay? Well, this says I can take the reciprocal of this and make one of these two adjustments, and it all depends on whether x is positive or negative. Now here we've got cotangent of a negative number. So I can use the reciprocal and tangent, but I need to use this version instead. So that this is going to correct the quadrant for me. So this is equivalent to pi plus tangent inverse of the reciprocal of this, which is negative square root 3 over 3. Okay. Now here we have a negative on the inside, and for tangent we know that it is an odd function, so I can switch this directly to minus tangent inverse of square root 3 over 3. And where is tangent equal to the square root of 3 over 3? That happens at pi over 6. So I have pi minus pi over 6, which gives me 5 pi over 6. It does give me an answer in the second quadrant, which is what I require for cotangent. Okay? All right, so now let's do cosine of pi over 6 plus inverse cosine of negative square root 3 over 2. So if I have cosine inverse of a negative number, what can I do? Cosine inverse of a negative, I can change that to pi minus cosine inverse of the positive version. So this is equal to cosine of pi over 6 plus pi minus cosine inverse of square root 3 over 2. Okay. Now where is cosine equal to the square root 3 over 2? Well, that happens at pi over 6. So what I have here is cosine of pi over 6 plus pi minus pi over 6. And those, of course, cancel out. And then what is cosine of pi? It's negative 1. Okay. So now let's talk about using a calculator for these, okay? Sometimes we're not going to be able to find an exact answer. That happens a lot. So your calculators will do these. You just have to make sure that you are in the correct format. If you're asked in degrees or radians, make sure that you're in the right form so it gives you the right answer. Okay? So if I'm doing this and I'm asked to find the value of y in degrees to 2 decimal places, so I am in degrees. I want to find sine inverse. On a lot of these buttons, a lot of these calculators, you'll either hit it twice to make it happen, you'll hit second, and then sine to get the inverse function, something like that. But you type it in here. We're asked around to 2 decimal places, so this is approximately 13.30 degrees. Okay. Now find cosecant inverse of 6.8. I'm going to be using, since this is cosecant and your calculators can't do those, we have to be smarter than them. So I'm going to look to see the relationship between cosecant inverse and sine inverse. And so here it looks like I can just take the reciprocal without worry. No adjustments required. So this is going to be equal to sine inverse of 1 over 6.8. Okay, which is approximately, so sine inverse of 1 over 6.8, and that is approximately 8.46 degrees. Okay? So let's look at some composition properties, okay? Sine, inverse, and sine, they undo each other, but again, we have to be aware of what answers they're going to give us in what areas, because it's possible that we're actually looking for an angle in a quadrant other than one of the ones that our inverse will give us, okay? But in general, let's just do this, okay? So tangent inverse of tangent of pi over 4. Let's just use our unit circle. What is tangent of pi over 4? Well, that's 1, okay? That's right here, okay? And then inverse tangent of 1 is also pi over 4. So in this case, we took the tangent of a number in first quadrant, we found inverse tangent, we got the answer back in first quadrant. So this is pi over 4. Okay? Cosine inverse of cosine of 5 pi over 3. Okay? 5 pi, cosine of 5 pi over 3. There's 5 pi over 3. Cosine of 5 pi over 3 is 1/2. Okay? It's 1/2. Okay. Now, for cosine inverse of 1/2, where does that happen? Well, cosine inverse only gives us answers here and here. It does not matter that we were finding the quadrant that we are dealing with here with an angle that's in the fourth quadrant. It's going to give us an answer in the second quadrant. Okay, so whereas 1/2 it's going to give us an answer here in the first quadrant, sorry, because of cosine. So cosine of 1/2, cosine inverse of 1/2 is pi over 3. This is what I mean by you can't just say, okay, well, cosine inverse of cosine of 5 pi over 3 is just 5 pi over 3. It's going to be something that has the same reference angle as 5 pi over 3, but it might not be the exact one. Okay, so now let's look at some harder problems here. Okay, sine and cosine, we know that They don't undo each other. They don't reverse things. So how can I do this? Okay, I want to find sine of cosine inverse of 3 over 4. Well, cosine is positive here and here, okay? But we're dealing with cosine inverse, so of a positive number. So we're going to be looking at something in here. Okay, so we are located in the first quadrant. That's what I know, all right? So I have a circle, a very bad circle here. I have something like this, okay? So I have a triangle here. I don't know that I'm on the unit circle, whatever. Now remember with cosine, you have x, y, and then this is your r. And for cosine, it's always your x over your r. So this is 3, and I don't know what this value is right here. But if I'm going to find sine of it, sine is going to be your y coordinate over 4, whatever that is. Well, I have a right triangle here, so I can use the Pythagorean theorem to find the length of the side. That's going to be 3 squared plus y squared equals 4 squared. So y squared equals to 16 minus 9. Y squared is 7. So y is equal to plus or minus the square root of 7. Now we know that since our cosine is positive and we found the inverse cosine of it, we are in the first quadrant. So I'm going to use the positive version for this. Okay, so this is square root 7. So what is y equal to? Y is equal to square root 7 over